Now we're going to talk about brain development in infants. First, some basic neuroscience terms. You should have learned all these before, so this should just be a review. Neurons. These are the basic cellular units of the brain and nervous system that specialize in receiving and transmitting information. Essentially, they're the basic units of the whole nervous system. They carry all the information from your body to your brain and back again. We're not really going to deal with the anatomy of a neuron right now, but you can learn more about that if you're interested. During pregnancy and during the first 2 years of life, neurons grow like mad. It's an amazing time for brain development. There are somewhere between 50 and 100 billion neurons in the adult brain. There are even more in a baby's. Neurotransmitters are the chemicals that carry messages between the neurons. Remember, the neurons don't actually touch each other, so they need these neurotransmitters to transmit the information. The cerebral cortex, that's the wrinkled part of the brain that manages the many higher functions that are considered unique to humans. Different regions in the cortex handle different things. The frontal cortex handles most of our higher functions. It regulates emotions, plannings, personality, etc. We will talk a lot about the frontal cortex. Hemispheres. These are the sides of the brain, left and right. Left is generally the source of language, logic, lists, its organization. The right hemisphere is the creative side, images, tone of voice, spatial skills. So you can think of left being more literal and organized, and right being more creative and about non-language tasks. The corpus callosum is a thick bundle of neurons that connects the two hemispheres. This is how the hemispheres talk to each other. When infants are born, their corpus callosum is not very well developed at all. So, growth of the brain. Myelin. This is a fatty wrap that speeds neural transmission. It's the insulation on the wires that are the neurons. The brain in infancy is not very myelinated, which means signals are inefficient and somewhat chaotic. Think about electricity running through a wire. Would you want to touch a wire without insulation on it? No, because that electric current can go anywhere. It wouldn't be efficient. But you put the insulation around the edge and suddenly the current can get from one end to the other much faster, much more efficiently. That's what myelin does for the brain. Myelin of the motor area of the cerebral cortex develops during the last month of pregnancy and continues after birth. The development of this myelin coincides with the baby getting his movements under conscious control. Myelination for the muscles is largely complete by age 2, but some development continues through adolescence, especially in the frontal cortex. Remember, it's not done until your mid-20s. At birth, myelination of vision, hearing, and skin is not yet complete, so their senses are not fully developed when they're born. As it progresses, children become increasingly able to integrate the sensory motor activities. Myelin is very, very important when we talk about brain development. Synapses. These are the connections between the neurons. Infants have more connections between neurons than adults. In fact, they have too many. It's inefficient. When they're trying to send a language or a signal from one part of their body to another, it has too many paths to go on. It's not taking the shortest, most efficient path because they have too many synapses. So what the brain does is something called pruning. In order for a brain to get more efficient, it has to undergo synaptic pruning. So think of plants. Pruning them can actually make them healthier, cutting off the branches that aren't needed. So connections that are not activated shrink and disappear. This is called pruning. Example, language. We've had this example a couple of times. Babies are born with the ability to hear all of the different sounds in all the different languages. As they are exposed to their native language, the synapses for the sounds they hear get stronger, and the ones for the sounds they don't hear get pruned. And this helps make the brain more efficient because signals are no longer using pathways they don't need. So we see an increase in brain mass. At birth, the brain is already nearly a quarter of its adult weight. By age 1, the brain is at 70% of adult weight. It grows that fast. This shows you how rapidly the brain grows in the first year and demonstrates the cephalocaudal trend of development. The head and the brain grow much faster than the rest of the body. There is an environmental role in brain growth. Nutrition, physical movement, and sensory stimulation can greatly affect the development of the brain. Remember the abused brain image? Physical movement has been shown to stimulate the brain, even in older age. It's not just kids. So physical movement is not just good for muscle health, it's good for brain health. And they need sensory stimulation. They need to have things to see and hear and smell and touch to stimulate the different portions of their brain. Otherwise, the portions of their brain could undergo pruning that you don't want to see. Animals raised in darkness show shrinkage of the visual cortex, for example. So, what do babies sense when they are born? What are their senses like? Where the sense of smell begins at 28 weeks of gestation. So, in the womb, they can smell. Babies can recognize their mother's scent, which is imprinted on them during pregnancy. Smell is the only sense where information is relayed directly to the cerebral cortex without going through the lower brain first. Because of this direct route, newborns rely on smell more than any other sense. This is also why smell triggers memory in you in such a way that no other sense can. Babies prefer things that carry the scent of family members, especially their mother. Infants also have an odor preference for mothers and lactating females. Newborns can use their sense of smell to help them nurse. So their sense of smell is the best developed sense when they're born. Taste. A fetus can taste in utero, and it recognized taste that it was exposed to while it was in utero. So more taste experience while in utero can mean a less picky eater later in life. So babies are born with a preference for taste that they were exposed to while they were in the womb. And they are also born preferring sweet tastes, and the reason for this is breast milk is sweet. So consuming sweets can be mood altering, it can be soothing, and that's why even as adults we go to sweets for comfort, because they probably take us back to infancy where sweet represented breast milk and the ultimate comfort. So we are born preferring sweets. So touch is not fully developed at birth. Remember, the myelination for that part of the body isn't done yet. Newborn girls appear to be slightly more sensitive to touch than boys. Newborn boys do feel pain, however, contrary to old beliefs. So when you are circumcising an infant boy, you need to make sure they are treated for pain. It used to be believed that infant boys couldn't feel pain, so they were circumcised without any sort of anesthesia. Babies deprived of touch, even if they're otherwise cared for, are stunted emotionally, physically, and cognitively. They have higher rates of sickness, weaker immune systems. It's more than just sensory. They need touch for social development and bonding. That skin-to-skin contact is super important. Babies need touch. There's a whole field of massage done for infants that can stimulate growth and IQ. It can help attachment. You can take classes in infant massage. And all of the infant's reflexes incorporate touch. So even though it's not fully developed yet, it's super important. Hearing. Babies show a preference for human sounds, talking, singing. Babies love motherese. This is a language or style of talking that adults instinctively use for baby. They slow down their voices, they pitch their voices higher, they really exaggerate the intonation of what they're saying. This is called infant-directed speech, motherese, or parentese. Babies love this type of speech. And people tend to do this naturally, and it helps baby learn language. Studies show that infants can recognize the voices they heard in utero, and they show a preference for their mother's voice. Babies have very good sound discrimination. Like we've said, they can hear the different sounds in every language, all the different phonemes. So infants are much better at sound discrimination than adults because of all those extra synapses. And this ability for sound discrimination peaks at around 6 to 8 months. So now we're going to talk about vision. Newborns can only see about 12 inches away from their face. If you think about it, 12 inches is about the distance from someone's arms to someone's face, or from mother's breast to mother's face. There's a reason this is the distance babies can see the most. So it's while they're being held, they are usually focusing on the face of the person who is holding them. By the first birthday, their vision is as accurate as adults. Newborns and older babies show a preference for faces over any other object. Within 3 days of birth, a newborn can distinguish mother's face. So again, babies spend most of their time focusing on faces when they're being held. Their preference for faces is adaptive. That means it helped us survive. It makes babies look at the faces of caregivers, which increases affection and bonding and makes it more likely that that caregiver will take care of the infant. So they love faces and they will stare at faces over any other object. Until 3 or 4 months, babies see very few colors. High contrast images are the best, such as black and white images or really bright colors. No pastels for babies, they can't see the difference. Babies will engage in what's called obligatory looking, that they will stare at something for up to 30 minutes at a time and they barely blink. If anyone has been subjected to a newborn stare, it is intense. This occurs when the visual cortex is beginning to exert control over the visual processing center. So they're starting to get control over what they look like and what they look at. Visual tracking. This is when you follow something with your eyes. Newborns have a very hard time with this. If you try it with them, you'll notice their eyes don't move smoothly. They jerk around and jump around. They may also lose the tracking when you cross the midline of their face, and it's because the two hemispheres of their brain aren't talking to each other yet. So that leads us to depth perception. In order to have depth perception, you need binocular vision. Both eyes have to work together, but they don't in newborns until about 4 months. Their corpus callosum is not very developed yet, which means the information from each individual eye doesn't communicate with the other. Our eyes see a slightly different scene, which is part of depth perception. It's how 3D images work, but babies can't integrate those two images yet. Motion helps. Babies can process motion by about 1 month old. They blink if an object comes toward their face. So they don't really develop depth perception until about 7 months old, which is also about the time they're learning to crawl. So again, this is not a coincidence. To demonstrate depth perception, I like to show you this visual cliff video. I can't show it to you here, and I wasn't able to find a YouTube link for this video. So if you can't play this embedded video, just look up the visual cliff and see what that's all about. It's a classic experiment that shows how babies deal with an apparent cliff, but it's not just about depth perception. They wanted to see whether or not the babies were afraid of the drop or if they would try to cross it and have no care about the drop. So what this experiment determined was that experience is crucial for the baby to develop a sense of depth perception and the understanding of things such as drop-offs. What they found was that babies who hadn't learned to crawl or had just started to crawl showed absolutely no fear of the drop and crossed the plexiglass without any concern whatsoever. But babies who had been crawling for a few months suddenly showed a fear of the cliff and wouldn't cross it. So they need depth perception, but they also need to understand what that depth means. This seems to develop not at a certain age, but at a certain stage of development. It's as though crawling around teaches them about these things. And this is an extension of the visual cliff experiment. This is learning about heights and learning about the relationship between our body and the environment. So it's showing children a ramp and seeing if a kid feels it's safe to go down that ramp or not. And it's a really fascinating video. And again, I would like you to watch this video and see how they experiment with infants and some of the things that they've learned. In the next video, we're going to talk about motor development in infancy.